Hello guys, welcome to the lecture series of Computer Organization and Advanced Microprocessors. This is our lecture number 33, and in this lecture we are going to study register organization for 8086 microprocessor. So let's start. Okay, so before we go for the register organization, let's discuss some important points about the registers. So basically we know that registers are reside inside the CPU, right? Here you can see that here we have the RAM and this is the CPU. The CPU contains ALU along with some other registers. So all are the registers. So we know very well that what is register? Registers are the special type of memory, right? Because this register contains only one bit at a time, and as we have already studied about this, that registers can be designed to the flip-flop, right? Of course it is used for moving the data, right? Because we know we use it for moving the data, because as we know that inside the processor there are multiple registers, right? And because processor is working on the data, all these registers have to be active, right? Quickly it transfer the data very quickly, it process the data, transfer the data, it moves the data very quickly. So of course it is vital for moving the data. Next point says handle the process of execution effectively and efficiently. Of course, because all these processor registers are resides inside the CPU, inside the CPU. So of course, execution becomes very effective and efficient because of the small gap or no gap kind of, we can say, because all are situated very near to each other, and that is true inside the processor. Of course, we know that it's a part of CPU, right? It's a part of CPU, but not the part of memory. See, keep in mind, as you can see this diagram, see this diagram, see this. This has two sections. This is the RAM and this is the CPU. So you can always find the registers inside the CPU, not in the RAM, right? Not in the memory. Okay, so next point says hold one piece of data at a time. Yeah, we already studied this very many times, that it holds one piece of data only, that is only one bit at a time, right? One bit at a time. Okay, so next point says receive information, hold it temporarily, pass it on as directed by the CPU. Simple. We know that registers normally behave like a buffer, right? Because whatever the data, whatever the instruction CPU gets, it needs to store that data on temporarily. And so we have register. So what happened first? It receives the information, then it will hold the data temporarily and it will pass it on as directed by the CPU. Whatever the CPU will direct, it will do accordingly. The next point says varies from computer to computer. Of course, because configurations are always vary from system to system. So the organization of registers, even types of registers, may vary from computer to computer. Remember about the scalar and vector processors, so it is based on that only. Then the next point says each designed to perform specific tasks. Yes, that we will see in the next slide, because we have many different types of registers and each register has a different task, or we can say that each register has been designed in a such a way so they can perform some specific task only. So specific task. Next point is specific storage capacity. Of course, see, suppose let's take one example over here. Let's say suppose I have register A, but this we know that single register can store only one bit at a time. But let's say this A series of A has four registers inside this range. So I have A0, A1, A2 and A3. So here I can say the storage capacity of this A register series is 4 bits, right? It varies from system to system. But yes, one register can store only one bit at a time, but so registers come may come in a group, and that's why here we are talking about the storage capacity. Okay, and the last point is normally how many registers? Normally 14 registers. Normally 14 registers you can find in a single microprocessor. Remember this point, 14 registers you may find in a single processor. So these are the important points about the registers. Now we'll see that how many different types of registers are there, and after that we will go for the register organization. So after the registers points, now let's see some commonly used registers. There are total 8 registers are there which are commonly used. We know that there are total 14 registers inside the processor you can find, but 8 registers are commonly used register. Now let's check it out all the registers one by one. Okay, so the first register we have accumulator, and we call it AC. So as we know that ultimately registers are going to store some data, because registers are nothing but the memory component, right? The smallest memory component, and this accumulator is going to store something. Okay, so it is going to store something, but going to store what? It is going to store the result. But result of what? So the result of last processing step of the ALU. What does it mean? Let's see. Let's take one example. Let's say, suppose I have two instructions. First instruction is 3 plus 5. Let's say 3 plus 5. And second instruction I have 4 minus 2. And currently my ALU is working on the second instruction. In that case, I can say that my AC register has 8. Why? Because I got 8 as a result of the last processing step, right? So my AC contains 8. So this is about the accumulator. Now second and third, we'll take both the register together. It will be easy to understand. So here we have memory registers. Okay, both are memory registers, but what is the difference? See, here it's a address, while here it's a buffer. So name itself says that this register is associated with some address, and the third one is associated with some data. So second register, memory address register, is called MAR. Memory buffer register is called MBR. Both the registers are connected with something. Connected with what? Connected with some bus. But because this is address register, so it is connected with the address bus, and this is the buffer register. So of course buffer is a term which we use for the data, so it is connected to the data bus. Now because these are the register, they are going to store something. Okay, fine. So this is the address register, so it is going to store the address, and because this is buffer registers, it is going to hold the data. Whatever the either it's we are talking about the address or the data or whatever, but ultimately what we need when we perform the read and write operation, if only at that time we need address, only at that time we will have the data, right? So if you are performing read and write operation, so in that case data will be stored in the buffer temporarily, and whatever the operation you are performing, read or the write, but where you want to write and from where you want to read, that address is going to be stored in the MAR register, right? So this is about the MAR and MBR. Now next we have instruction register. See the fourth one. This is the instruction register, and in short we call it IR. IR is also called as a current instruction register. CIR. Sometimes we call it current instruction register. Name itself suggests that it holds. Of course, it's a register, so it is going to hold something. It holds what? The instruction. Okay, instruction currently being executing or decoded by the CPU. So instruction register or IR is a register which stores the current instruction which is actually being executing by the processor, by the CPU, whatever it is, execution process or a decoding process, whatever. But because it's in a it's a current execution, it's a current decoding process, so at that time that instruction will be stored inside the IR register. Fine. Okay, the next we have program counter. Okay, it's very easy. Program counter in short we call it PC. See, n number of instruction you may find in a single program during the execution, but how the processor will know, how it will calculate the time? So based on the program counter, because program counter always holds the address of the next instruction which is going to be executed next. So processor comes to know that okay, I have next instruction, okay, I have next instruction. So the length of the program or a length of the total instructions we require, so CPU can calculate the timing. But for that CPU must know that is it the last instruction, is it the last instruction. So to know that, we have a program counter, and this program counter holds the address of the next instruction, right? Okay, then we have 6 and 7 will take together. 6 and 7 both are the input output registers. Both are the input output register. See, ultimately when we talk about the read and write operation, but without input output devices we cannot perform any operation. So here we have two exclusive registers. One is related with the data and the second is related with the address. So IODR and IOAR both communicate with what? With the IO devices. Both communicate with the IO devices, but IODR communicates for the data while IOAR communicates for the address. From name itself you can identify that IO address or IOAR communicate with IO devices for address, right? So this is about the 6 and 7 register, IODR and IOR. And finally the last register we have, and this register is a general purpose register. It is like you can use this register for anything. Suppose all the registers are full. In that case, suppose you want to store something else, in that case you can use general purpose register. Means it can store anything. It can store data, address, anything you can store. So it is a general purpose register. So this is about the 8 commonly used registers. So here we have 8086 register organization. This is the picture of all the registers which are organized inside the 8086 processor. So how all the registers are organized, how they are grouped together, that we will see. So the very first group is of the general purpose register, and this group contains total 4 or total 8, normally 4 registers. Accumulator we have, then we have a base register, then third is a counter register, and the last one is a data register. Now they normally we call them AX, BX, CX and DX. You can I'll write the name here like A, B, C and D. So this is my first group for the GPR, and this AX, BX, CX and DX are divided in two ways. This is called the AH, that is high, and this is for the low bits, and this section is for the high bits. The next one is the pointer. So this pointer group contains total 3 register. Stack pointer we have, then we have a base pointer and the instruction pointer. So this three pointer we have, we call them S, B, I. So A, B, C, D, then we have S, B. This is just a trick to remember. Okay, right? So these three registers we have: stack pointer, base pointer, and instruction pointer, which comes under the pointers group. Next group we have index registers. All the index registers we have. So in index registers we have total two indexes. Okay, index registers, and in that we have total two register source and the destination. See, indexing is normally we need during the stack and queue, right? So source means from where you want to take the data, and destination means where you want to store the data. So we have source and destination index. The next is okay, the next we have segment register. Next we have segment register. Segment register contains different types of code, sometimes data, stack, and we have also extra segment which can store anything, or extra data we can say. So these are the segment registers. So after A, B, C, D, S, B, I, then we had S, D, then we have C, D, S, E group, and the last one we have flags, right? So the last group of the registers we have status register, and this status register contains different types of flags just to indicate the status of particular process, right? So this is the organization of all the registers inside the 8086, which is actually divided into 5 groups. Each group contains some certain registers, important registers. The first group contains ABCD. Okay, the first group contains the ABCD 4 registers. The second group contains SBI we have, right? We have SBI. Okay, let me write again. SBI we have. Then we have SD. Then we have C, D, S, E, and in the last we have F. So this is the 8086 register organization. So it was all about the overview of the register organization, that how all the registers are organized in 8086. Happy learning. Thank you.